Yes. So yesterday we stopped at this question and I asked you to complete the remaining portion of this question. We did 1, 2, 3 parts and I asked you to complete 4, 5, 6, 7. Parallelogram law of vector addition. Two vectors and angle between them is given and we want the resultant in different cases. So we did for 0 degree, 180 degree and 90 degree. The other angles are 30, 45, 60 and 120. What is it for 30 degree? Theta equal to 30 degree. Resultant is root of p square plus q square plus 2pq cos theta, which is root of p is 6, q is 8. So 6 square plus 8 square plus 2 into 6 into 8 into cos 30 degree. That means the two vectors will be like this. This is vector P, which is 6 Newton. And this is vector Q, which is 8 Newton, making 30 degree angle with each other.
So cos 30 is root 3 by 2.
This is 36 plus 64 plus 2, 6, 12, 12, 8, 96 into root 3 by 2.
Sir, we can cancel 2 and 96.
This is 36 plus 64, 100. 48 root 3. And if you want to simplify it further, value of root 3 is 1.732. We can multiply 48 with 1.732 and add it to 100 and you will get the root of that thing. That is the thing. This is for 30 degree. What about 45 degree? And to be able to do all these things, first of all, you should have clarity on, you should remember the trigonometric values for sine, cos, tan for 0, 30, 45, 60 and 90 degree at least. Then theta equal to 45 degree. Root of 6 square plus 8 square plus 2 into 6 into 8 into cos 45. Cos 45 is 1 by root 2. 1 by root 2. This can be simplified further. 36 plus 64 plus, I can write this 2 as root 2 into root 2. This 2, root 2 into root 2. So 1 root 2 will be cancelled. This root 2 will be cancelled. You have 6 8 48. 48 into root 2. And value of root 2 is 1.432. You should remember these two values. We use them frequently in physics. Root 3, 1.732. Root 4, 1.432. So we can do that multiplication and add it. Theta equal to 60 degree. Resultant will be 6 square plus 8 square plus 2 into 6 into 8 into cos 60 is 1 by 2. So 2 cancelled. You have 36 plus 64 plus 48. So this is root 148, which is 12 point something, approximately 12.1. So the simple situation, simple question based on parallelogram law of vector addition. You should remember the formula. Identify what is given, or two vectors given, angle given, what is being asked, resultant is asked, or the angle between them is asked.
Sir, now should we do the 60 degrees question, sir?
No.
Sir, can you sir, can you scroll down?
Sir, can you scroll up? Okay, sir.
Right. Parallelogram law, very important thing. Next thing that we must learn in vectors is the resolution of a vector. Okay, or before this, I think, okay, we will do one or more examples to understand parallelogram law more clearly. Okay. Say we have two vectors, two vectors, three Newton and 4 Newton are making, okay, not Newton, you take it, say some any unit, two vectors having magnitudes 3 and 4 are making angle 60 degree with each other. Find the magnitude and direction of their resultant. Magnitude and direction of their resultant. We have two vectors. This is 3 units magnitude. This is 4 units magnitude. Angle between them is 60 degree. Now we want the magnitude and direction of the resultant. The direction resultant will be something like this, R. What is the magnitude and direction of this resultant? Okay.
Sir,
Resultant of,
is the magnitude root 37?
wait. The magnitude is given from directly you substitute the values in parallelogram law. The magnitude is given by R is equal to root of P square plus Q square plus 2PQ cos theta. P, Q, theta are directly given in the question. So it is 3 square plus 4 square plus 2 into 3 into 4 cos 60. 9 plus 16 plus 24 into 1 by 2. 2 ones, 2 12s. So this is root of 16 plus 12 is 28. 28 plus 9 is 37. Root 37. Approximately 6. Not exactly, approximately 6. This is the magnitude. What is the direction? The direction
Sir, I'm getting 2p cos theta by 2.
of
Direction.
the resultant is, if you remember, I told you to remember two formulas. One for the resultant, other for the direction, which is tan alpha. Tan alpha is equal to q sine theta by p plus q cos theta. If you complete this parallelogram, parallel to 3, parallel to 4, the resultant will be the diagonal of the parallelogram, and this resultant is making angle alpha. This angle alpha is given by this formula, q sine theta by p plus q cos theta. In place of p we have 3, in place of q we have 4. Theta is 60 degree. So q sine theta means 4 sine 60 divided by p plus q cos theta. P is 3 plus q is 4 cos 60. 4 into sine 60 is root 3 by 2 divided by 3 plus 4 cos 60. Cos
1
60
by
by 2. 4 by 2 is 2. 3 plus 2 is 5. So this is 2 ones, 2 twos, 2 root 3 by 5. So tan alpha is equal to 2 root 3 by 5. That means alpha, we want angle, not the trigonometric ratio. So alpha is tan inverse of 2 root 3 by 5. This is the direction. This is the magnitude.
So tan inverse means divided by, sir.
If I say that sine 30 degree is 1 by 2, that means 30 degree is, when if I send this
Okay.
sine to the other side, it becomes sine inverse or 1 by sine 1 by 2. Next question, 1 minute.
Sir, can you scroll up a bit?
Sir, are you saying anything?
Oh, wait, just a minute. I'm giving you a question.
Sir,
Yes, just a minute. Okay, right. We'll come to these questions later. Let us go to the next topic, which is resolution of a vector. Important
sir,
one.
can you scroll up? Yes, sir. Here I have a doubt.
Yes.
Yes, sir. That means you wrote the direction of the resultant is given, no, sir.
Mm.
Sir, but you wrote only tan inverse 2 root 3, no, sir. Is it from x-axis or y-axis, sir?
How have we defined that in the basic formula? With respect to? We have defined angle alpha with respect to x-axis, with respect to horizontal. The same holds here also.
Okay, sir.
Resolution of a vector, or this is also called rectangular components of a vector. Rectangular components. Both mean the same thing. What is this? Important thing. To understand this, suppose these are the xy axis. If I have a vector which is like this, let us say this is some vector A. This is vector A. It has some magnitude. Its direction is towards x-axis. It has some magnitude, 2, 3, 5, 10, some magnitude. If I ask you, what is the value of vector A along x direction, you will say that its value is equal to its magnitude. Okay. What is the value of vector A along y direction? Value of vector A along y direction. Okay, let us say I will give you vector A, its magnitude is some 5 units. The value of vector A along x is how much? 5 units. Vector has both magnitude and direction. Vector has both magnitude and direction. Vector A is a vector whose magnitude is 5 units and its direction is towards x-axis, positive x-axis. So if I ask you what is the value of vector A, indirectly it means what is the magnitude of vector A along x direction. It is clear from there, 5 units. If I ask you what is the value of vector A along y direction,
0, sir.
it is 0 because vector A is not at all in y direction. It's completely pointing in x direction, horizontally. So it has no value or it has no magnitude along y direction. If I take another vector, this is vector B, this is vector B. Let us say this is also 5 unit. Now if I ask you what is the value of vector B in x direction is value of vector B along x direction is 0. It's not at all pointing or it is not at all existing in x direction. So its value in x direction is 0. If I ask you what is the value of vector B in y direction, answer is 5 units. Is this point clear?
Yes.
If I give you a third vector, which is vector C, which is also 5 units in magnitude, and its direction is like this, and ask you value of vector C in x direction is, it is not 0. It has some value, right? Similarly, value of vector C in y direction is also not equal to 0. Vector C has some magnitude or some value along x direction. It has some value, some magnitude along y direction also, because it is lying in xy plane. It is lying in xy plane. X vector A was only along x direction. Vector B was only along y direction. Vector C is in both x and y directions. So it is both in xy directions. It will have some magnitude along x direction and some magnitude along y direction. We call these magnitudes of this vector as components of a vector. Components of a vector. So components of a vector are the magnitudes of that vector along mutually perpendicular directions. That is nothing but x and y directions. So the value of a vector or the magnitude of a vector along two x and y directions, we call it as components of a vector. It is just like imagine you are
Sir, once.
okay, this is your room. This is the floor of your room, and you are here at one corner. Okay. take this as x-axis and take this as y-axis. If you walk along this line, you are moving only along x direction. You have only x coordinate. If you are moving only along this line, you have only y coordinate. But if you are walking like this, let us say, then you are somewhere here. Then you have moved a certain distance along x direction and a certain distance along y direction. Then you are here. Okay. If I show your position by drawing a position vector, which is this is your position vector. Then this position vector has some value in x direction, some value in y direction. We call these two values or these two magnitudes as components of this vector. Okay. That is the basic idea behind components. Now trying to understand it technically, I'll take a coordinate system. X-axis, y-axis, and in this, I am taking a vector. This is vector r. And it is making angle theta with x-axis. Okay. Now, as we were discussing, this vector r has magnitude both along x and y directions. It has some value along x direction, some value along y direction. We call these values as components of a vector, components of vector r. How to find these components? Simple. To find x component, or we also call this as horizontal component, from tip of vector r, you draw a perpendicular onto x-axis. Okay. Then this value right from here to here, is this the value of vector r along x direction? Yes, it is the value of vector r along x direction. So I will call it as rx. Rx means component of r along x direction. Okay. And what is the value of vector r along y direction? Same thing. You draw a perpendicular from tip of vector r onto y-axis. It is cutting it here. That means this is the value of vector r along y direction. And we will call this as ry. Component of vector r along y direction. So now rx and ry are components of vector r. Consider a vector r making angle theta with x-axis. Okay. Then
Sir,
the component, yes.
Sir, once can you scroll up? Sir? Sir, that means you wrote the components of a vector or the magnitudes of that vector along mutually means what, sir?
Perpendicular to each other. X and y are mutually perpendicular to each other.
That means what, sir, mutually means?
Perpendicular to each other mutually among themselves.
Okay, sir.
So we are considering a vector r which is making angle theta with x-axis, and the component of vector r, along x direction is rx, and we can write rx. How can we write rx? Right, see, I'll call this as this is O, this is A, and this is B. OAB is a right angle triangle. OAB is a right angled triangle. In this right angled triangle, from triangle OAB, I will write cos theta adjacent side by hypotenuse. Adjacent side is OB. Hypotenuse is OA. That means cos theta is equal to OB is nothing but the component of vector R, Rx along horizontal direction, by OA is vector R. So we have Rx is equal to R cos theta. Rx is R cos theta. Next, the component of vector R along y direction is Ry. We have given it the name Ry. How much will be this Ry? To find this Ry, we do the same thing. From triangle OAB, same triangle, right angle triangle. See, if this is Ry, if this is Ry, this is also Ry, because it forms a rectangle or a square. The opposite sides will be equal. So we can take this side also as Ry, they will be same. Then from triangle OAB, if I write sin theta is opposite side by hypotenuse. Opposite side is AB, hypotenuse is OA. That means AB is nothing but our component Ry. OA is vector R. That means Ry is equal to R sin theta. Ry is equal to R sin theta. These are the two components of vector R. What do these components tell you about? They tell you how much is the value of vector R along x direction and how much is the value of vector R along y direction. We call them as components of vector or rectangular components of a vector, or we call this process of resolving a vector into two components as a resolution of a vector. Resolving means breaking down or splitting a vector into two perpendicular components. We call this as resolution of a vector.
Sir, can you spell? Sir, upset. Sir,
Resolution of a vector. If a vector is given to you, if its magnitude and angle are given, you must be in a position to resolve it into two perpendicular components very, very clearly without any problem or confusion. This is a very important part in vectors. In the physics that you are going to study in our higher classes or even in our coming classes, we will be mostly using these two things from vectors. One is applying parallelogram law, other is resolving a vector into two components. If you understand closely, observe and understand closely, in parallelogram law, you are given two vectors, P and Q, making some angle theta with each other. Then what you do is you combine these two vectors. You are doing P plus Q, vector P plus vector Q, and you are getting a resultant something like this. That means you are adding these two vectors, you are combining these two vectors by applying parallelogram. Whereas in this process of resolution of a vector, you are given a single vector R, making some angle theta with some reference x-axis. Here you are splitting this one vector into two vectors. One is r cos theta, other is r sin theta. So these two are reverse processes to each other. You can understand it in that way. Parallelogram law combines two vectors into one. Resolution of a vector divides a single vector into two parts. These are two most important operations that you must be able to do on vectors. If you can do these two things clearly, almost 70% of vectors is, you have understood 70% of vectors by doing only these two things. Suppose if I give you if I tell you this is a vector, let us say some 10 Newton force, it is acting at 30 degree with x-axis. Then find the components of 10 Newton along x and y directions. Simple. Component of 10 Newton along x direction is, I draw a perpendicular here, then this becomes r cos theta. Remember, see one important point here. So we'll get two components. One is r cos theta and the other r sin theta. What is r? Magnitude of the given vector. Here in this r or this r, it is magnitude of the given vector. And what is theta? Angle made by the given vector with horizontal. Mostly, in most of the cases, it will be x-axis. It can be even y-axis also. Okay. Using these two things, we have to find Rx and Ry. And many students, what they do is, from this discussion that we have done, they remember it like the component which is along horizontal direction, they remember it as Rx, and component along vertical direction, they remember it as Ry. It is not always true. Don't remember it that way. You remember it like the component R, we are doing two components of R, right? This is one component Rx, and this is the other component Ry. Now, the component to which the angle is attached, the component to which angle is attached, to which component is angle attached? It is attached to Rx, because angle theta is here. It is attached to this Rx component. This component will be cos. That's why you have got Rx is cos theta. And the other component which is not attached to the angle, Ry, it is not attached to the angle. Okay, that will be sine. That's why Ry is sine. This will be true everywhere. A shortcut to remember which component will be cos component and which component will be sine component is to remember like the component which is attached to the given angle theta will be cos, and the other component which is not attached to the given angle theta will be sine. Now coming here, this vector 10 Newton making 30-degree angle will have two components. This is one component along horizontal,
Sir,
this is the other component along vertical. This is
diagonal.
Rx, okay, R, this is X component, this is Y
Y.
component. So X component,
Sir, R sin theta.
X component is 10
New
sine
sin theta.
30,
30.
which is 10 into 1 by 2, which is 5 Newton. Y
Sir,
component,
isn't x component means cos theta, sir?
cos 30, 10 cos 30,
Root 3
cos
by
30 is
2. 5 root 3.
10 into root 3 by 2, which is 5 root 3 Newton. And Y component, vertical component, is 10 sine 30, 1 by 2,
5.
5 Newton. So if a 10 Newton force is acting, making 30-degree with X axis, it is equivalent to 5 root 3 Newton acting along X direction and 5 Newton acting along Y direction. If you combine these two things, see what we are doing here is we are splitting a vector into two parts. And if you have splitted it correctly, if you add these two parts, again you should get the same vector, right? Like it's like, suppose you have your pen, you can disassemble your pen, right? You can separate the cap, you can turn that knob and you can take out the refill. You will get 3-4 parts of your pen. We have resolved your pen into 3-4 parts. Okay. Now, if you again arrange them properly, you should get your pen back in the same form. Similarly, this 10 Newton force we have divided, we have split it into two parts, one horizontal and one vertical part. The magnitudes of those parts are this 5 root 3 and 5. If this is correct, then when you add these two parts, when you combine these two parts, you should get the same vector. Then what you have done here is correct. So let us check whether we have split it correctly or not. To check what do we do? We have now, I have 5 root 3 Newton in X direction and 5 Newton in Y direction. Okay. Now I want to combine them. Combining means adding. Adding means finding resultant. The resultant of these two vectors is how can we find resultant of these two vectors?
Sir, here, by the way, the angle between x and y coordinates is 60 degrees, sir.
Angle between X and Y axis will always be 90 degrees in anywhere, anytime.
Okay, sir.
That's
Okay,
why we
sir.
call them as mutually perpendicular. So I want to combine these two vectors, 5 Newton and 5 root 3 Newton. How can I combine? Do we know any law, any rule to combine two vectors?
Sir, for 90 degrees, we have a special case.
That is where we apply parallelogram law. Parallelogram law is used to add two vectors. Combining these two vectors means adding them. So to add these two vectors, you would apply parallelogram law. What does parallelogram law say? The two vectors are perpendicular to each other. 90 degrees is the angle. The resultant is root of p square plus q square plus 2pq cos theta. Theta is 90 degree. Cos 90 is 0. Therefore, you have r is equal to root of p square plus q square, which is p, this is 5 root 3, 5 root 3 whole square plus q, this is 5 square. 5 root 3 whole square is 25 into 3, 75. 5 square is 25. Root 100, which is 10.
10.
That means if you combine 5 root 3 and 5 as per vector rules, again you are getting 10 Newton vector, which is the original vector. Do you understand this point?
Sir,
Yes.
sir, can you once again explain where we have used sine theta and where cos theta?
If a vector is given to you like this, some x vector, it is making some angle theta with x direction. Then this its two components will be one along x direction, other along y direction. The component which is in contact with the angle, this here, this is attached to the angle. This component will be cos x cos theta. The other will be sine.
Okay, sir.
Okay, this is a resolution of vector. We have to do many questions on this to get clarity how to use this thing. We will do that in our next class. So see you and good night.
Thank you, sir.